Welcome students. Today we'll be studying how to solve system of linear equation using matrix inverse method. Sometimes it is also known as the matrix method. So in matrix method we can have two forms of equations. In the first form of equation we have ax equal to b. Then the solution for this matrix equation is given as x equals to a inverse times b. The second form of equation that we can have is x a equal to b. Then the solution for this form of equation is x equals to b times a inverse. Now we will look at the derivations for these two forms of equation. Number 1, given that ax equal to b, how do we solve this equation and get the solution? Firstly, we start by multiplying both the sides by a inverse. When we do that, we get a inverse ax equals to a inverse b. And then now in the next step what we have done is we have just rearranged the brackets in this part of the equation. Then we know that a inverse a is equal to I. Thus we have replaced this bracket with the I. Thus we get I x equal to a inverse b. And we also know that any matrix, when it's multiplied with the identity matrix, we get back the matrix itself. Hence, Ix equals to x will be equal to A inverse B. Here, now we have the second form of the equation, that is xa equals to b. Similarly, like in the first equation, we multiply both the sides by A inverse. Then we get x equals to A times A inverse equals to B A inverse. And this is the same step, we have just rearranged the brackets. And we already know that A times A inverse gives us a identity matrix, and identity matrix times any matrix is the matrix itself. So similar to the, so this derivation is quite similar to the first one, and hence we get hence the solution for xa equal to b is given by x equals to b times A inverse. Now let's look at the example for solving a system of linear equation using matrix inverse method. Okay, here we have been given two equations with two variables. So how do we solve? So firstly what we do is we write our given equation in matrix form. So we write down the coefficients of our equations as matrix A. As we have seen previously, for Ax equal to b, the solution is given by x equals to A inverse times b. And since, as we have seen in previous videos, A inverse is equal to 1 by determinant of A times adjoint of A. So if we replace inverse A with this in this equation, we get x equals to 1 by determinant A times adjoint A times B. So this is how we find the solution for our variable matrix X. So to solve the equation, we firstly need to find determinant of A and adjoint of A. From the previous question, we have written down the determinant of equation A. So determinant of equation A is equals to 8, and 8 is not equal to 0. Hence, it is a consistent system with a unique solution. Therefore, we know that we can now find our A inverse. To find A inverse, we need to find adjoint of A. And we know that for a 2 by 2 matrix, we can easily find the adjoint by changing the place of these two elements and changing the sign for these two elements. By doing this, we have obtained our adjoint of A, and our and our constant matrix B is also given here. And like we saw in the previous page, x is equal to inverse of A. Inverse, these two 1 by 8, this is the determinant part, this 1 by determinant, this is our adjoint matrix, and this is our constant matrix. So when we multiply these three, we get our solution. And 3 is our variable x and 2 is our variable y. Let's look at another example. Here we have 3 equations with 3 variables. To solve this system of linear equation, like we did in the previous example, we start by representing our equations in matrix form. So matrix A is our coefficient matrix, matrix X is our matrix of variables, and B is our matrix of constant. We know that if Ax equals to B, then X is equal to A inverse times B. So we need to find A inverse and then multiply it with B. So we start by finding the determinant of A. So we see here that the determinant of A is not equal to 0. Hence we know that system is consistent and has a unique solution. So next step, we find the adjoint, and we know that the adjoint is the transposed matrix of cofactors. Therefore we start by finding our matrix of cofactors. How to find the matrix of cofactors have been covered in previous lectures, so I have directly given the matrix of cofactors here. So after finding the matrix of cofactors, you can just transpose it. That is, all the row elements will be written as column elements. 0, 4, 4, minus 2, 1, 3, minus 2, 3, and minus 1. This is our matrix of, this is our adjoint matrix.
3.
We know that A inverse is equals to 1 by determinant times adjoint of A. Hence we can we just need to multiply the values that we got in the previous step. And we also know that x is equals to A inverse times B. So multiply A inverse with B, that is the matrix of constant. So firstly you can multiply these two matrices and you will get minus 8, 16 and 16. And then you multiply this with 1 by negative 8, you will get 1, 2, 2. Here 1 is your value of x, 2 is your value of y, is your value of z, and this is your solution for the system of linear equations.